Hey everybody, welcome back to another mini lecture on the brain. Last time we talked, we were in the frontal lobe. We were looking at the precentral gyrus, which if you recall is the primary motor cortex. We looked at the motor homunculus. Let's go back and look at him again just one more time, just because I just love looking at him. There he is. There's the motor homunculus, the little guy that shows us the dimensions of our body as experienced by that part of our brain, like how we devote more brain space to hand control and lip control than we do to, for leg control, for example. All right, let's talk a little more about that precentral gyrus, that primary motor cortex. What I've got going on here is the precentral gyrus up here. And what I want you to notice, again, notice the different regions associated with different parts of the body. But what I also want you to notice is where the axons are going. The axons from this gyrus, so we see these are bundles of axons here. Remember the neurons that were in the precentral gyrus, they were called pyramidal neurons. So the axons that project from them are going to be known as the pyramids. So like the bundles of axons are called pyramids. So anyhow, we see these axon bundles come down out of the cerebrum. They're now going into the midbrain, and then down the brainstem into the medulla oblongata. And in the medulla oblongata, notice it's labeled pyramids right here, we see a switching of sides. Now, the switching of sides gets a fancier name. That fancier name is the decussation of the pyramids. And what this ends up doing is giving our primary motor cortex contralateral control. What that means is that, like right now, we're looking at the left cerebral hemisphere, and it is going to control muscles on the right side of the body. So notice when we do the switch here, we switch from the left side to the right side, and we stay, we're coming down a column in the white matter of the spinal cord, and then we get into the ventral horn, and we're going out onto the right side, taking the spinal nerve on the right, going to skeletal muscles on the right. Alrighty, so that is pretty cool. Let's keep moving. Let's go a little bit forward. So we just did the primary motor cortex. It was right here. And now we're doing the premotor cortex, which is just in front of it. It is where we are going to have our learned and patterned skills. Think about how you do not need to do anything, or like not that you don't need to do anything, but think about how you don't need to think about it to tie your shoes. How you don't need to think about it. If you're like a musician, if you're a piano player, you don't have to think about like, okay, where are my fingers going to go now? You just do it. And this is a learned or patterned skill. And the signals for that start in this premotor cortex. Now, also, this is where we're involved in planning movements. So it's for learned and patterned skills, but also for planning movements. Okay, if we go a little bit down and to the front, we got this dashed area right here. This is called the motor speech area, also known as Broca's area, after Mr. Broca, this handsome looking devil right here. And this is kind of weird in that this area is usually just in the left hemisphere and not in the right. And what it is going to do is control the muscles of your tongue, your lips, your pharynx, your throat in other words, that are involved in the production of speech. This area is your motor speech area. I mean, it's your movements for speech. It is also involved in the planning of speech as well. All right, so we did our primary motor cortex, we did our premotor cortex, and we just talked about the motor speech area. So let's keep on moving in this frontal lobe. Notice how we're going kind of more and more anterior here. And now we got the prefrontal cortex, the anterior frontal lobes. And this is where we are doing all that higher executive function in our brain. This is where we're doing our analysis, our thinking, our cognition. This is where we have our own personality, our sense of humor, our sense of a conscience. This is where we have our ability to control our impulses. If you're hungry, you're not automatically going to steal your neighbor's food because you know that you should not do that. That's your prefrontal cortex in action. This is the last part of your brain to develop. Usually doesn't happen until you're in your early 20s. All right. Let's keep on going. This guy right here is a man who goes by the name of Phineas Gage. Phineas Gage. I don't know if it's G-A-G-E or G-U-A-G-E. I don't remember. But what this guy was, he was a railroad foreman. And it was probably in like the late 1840s. And he was working on basically clearing a path for a railroad line. And he was using an iron bar to tamp or push down some gunpowder. And what happened, surprise, surprise, the iron bar struck a rock. We had a spark, we had an explosion, and then that iron bar shot up through his face and through his skull. We see it going into his maxillary bone here. We see it coming out of the top of his skull right here. Went right through his left eye, and it damaged his frontal lobe. Now, what do you think happened to his personality, his sense of right and wrong, his sense of behavior control? Think about that for a little bit. And while you're thinking about that, I'm going to jump to the next slide. Here we go. We're done with the frontal lobe. And now we're moving backwards into our parietal lobe. The parietal lobe has a couple major parts we're going to need to know. First of all, there is the primary somatosensory cortex. I got a black arrow on it here. It is this blue gyrus right here. It is just behind the central sulcus, so that is why it is known as the postcentral gyrus. This is where information from sensory neurons in the skin and proprioceptors. So information about your body in terms of touch and position goes to this primary somatosensory cortex. Now bear in mind, it is also contralateral. So stimuli on the left side of your body go to the right cerebral hemisphere, the right primary somatosensory cortex. And take a look at that word, somato, body, sensory, of course, sensation. So touch and proprioception from your body. All right, this is the sensory homunculus. This is the demonstration of how much brain space in that postcentral gyrus you devote to different regions of the body. So there's some similarities from before. Big hands still, big lips, but now the eyes are smaller, the feet are bigger, the genitalia is bigger. Definitely some differences here. But again, it's a similar situation where we have different regions apportioned to different parts of this gyrus, and the more sensitive parts get more brain space. All right, that'll do it for this mini brain lecture. I will see you guys next time.